So before we can talk about chemical and physical change, we first need to talk about chemical and physical properties. So a physical property can be observed without changing what the substance is. Some examples of this are the color of an object, the solubility, if it dissolves, the odor, what it smells like, density, how much stuff is packed, how much matter is packed into a certain amount of space, the hardness, the melting point or boiling point, these properties are always going to be true for that particular substance. They will not change. Chemical properties can be observed when a substance goes through a chemical change. And this is the ability to undergo a chemical reaction. We have to change the object to see if these things exist. So some examples of chemical properties are flammability, rust or corrosion, so if your car is rusting, the metal will turn that reddish orange color. Corrosion will occur like with batteries. You'll have that white or greenish color. And this is going to be a color change. Whether it will decompose, or rot. And then whether it will explode or not. These are all chemical properties. So physical changes, we're altering the substance without changing its composition. The chemical makeup of the substance is going to stay the same. So the properties stay the same. Some examples of physical changes. If you buy whole coffee beans at the store, you can grind them up. Still coffee. If you're helping to make dinner, you can chop some vegetables. This is still going to be onions, still carrot, The chemical makeup of these have not changed. A soda can, after you're finished, you can crush the soda can, and it is still a soda can. And then a piece of metal silverware, you can bend it, and it's still a spoon. It might be a little bit harder to use, but it's still a spoon. Physical changes also include phase changes. So when we go from a solid to a liquid, it melts. When you go from a liquid to a gas, it evaporates. Excuse me. When you go back from a gas to a liquid, it's condensation. And a liquid to a solid, we're freezing it. Solid to a gas, that is sublimation. So an example of sublimation is if you take dry ice and you can put it in some water to speed up the sublimation process, but the solid CO2 will sublimate into a gas, and it normally hangs down low next to the floor, and that's because CO2 is more dense than the air. So people sometimes use this at Halloween to have that kind of smoky look that kind of crawls along the floor. And then going from a gas to a solid, as the weather cools down, especially at night, the water vapor in the air is going to go from, so water vapor is a gas, it is going to deposit on your windshield in the form of solid ice or frost. So gas to a solid, that phase change is called a deposition. And then chemical changes. The substance is changed into a new substance. The properties change. Or they are different. And there are 4 indicators of a chemical change that we're going to look at. The first indicator of a chemical change is a significant color change. So here in the video, they have 3 different beakers of clear solution, and as they pour them together, chemical reaction is taking place, changing from clear to the red color, and then the red to the dark purple or black color. We have 2 different chemical reactions that are occurring to cause this color change. That significant color change is an indicator of a chemical reaction. This fall, as the leaves turn color, there's a chemical reaction going on to change the color of the leaves. Rust or corrosion changes the color of the metal. So that is also an indicator of a chemical reaction. If you go home and you paint your nails, is that an indicator of a chemical reaction or a chemical change? No, because your nails, the chemical makeup of your nails is still the same. You're just putting something on top of them. Second indicator of a chemical change is the production of a new gas. So if you've ever made a volcano, out of baking soda and vinegar. You mix them together and it starts bubbling or fizzing. Those bubbles are an indicator of a gas. The key here is that it has to be new. It can't be a gas that's already there. Cow farts that smell like methane. There's a chemical reaction going on inside the cow's stomachs to cause the methane to be produced. So think about opening a can of soda. Is that an indicator of a chemical change? Well, we do have fizzing, we do have bubbles, but when they make the soda, they actually pump in CO2. So that CO2 is just being released into the air. So this is not a chemical change. Spontaneous change in energy in the form of heat or light. So if you've ever used the hand warmers to keep your hands warm at a football game, you snap them and then the chemicals mix. They produce heat because it is an exothermic reaction. Same thing for the trainers that have the ice packs in their bags. It tells you to squeeze it together. You're mixing the chemicals. It becomes cold, so this is an endothermic reaction. For glow sticks, we have a hydrogen peroxide solution that mixes with the phenyl oxalate ester and a fluorescent dye. And as those mix, a chemical reaction is taking place that produces light. So the light will continue as long as there are chemicals that are able to undergo the chemical reaction. Once all the chemicals have been used up, the chemical reaction is going to stop, which means that there will not be any light. You may have tried to put your glow sticks in the freezer to try to preserve them. Well, the reason why that doesn't preserve them for forever is because the chemical reaction isn't stopping, it's just slowing the chemical reaction down. And then our last indicator of a chemical change is a formation of a precipitate, formation of a solid. So we have a test tube here of a clear solution, and then they're dropping a clear solution into it. So this is lead nitrate and potassium iodide being mixed together. The yellow solid that is now falling to the bottom of the container is lead 2 iodide. And that is the solid that is being formed by mixing the two solutions together. So that is a formation of a precipitate. Do not confuse the precipitate with precipitation, because precipitation is a different thing. That is actually a phase change, and so that is not a chemical change. That is it for today's notes. On page 6, you have a practice for chemical and physical change. Go ahead and apply what we just talked about in the video to that. You will be having a homework quiz over classification of matter as well as chemical and physical change. So make sure that you are prepared for that. Thanks for stopping by. Have a great day.